Welcome to the SU-25T Frogfoot. The Frogfoot, also called the Carnage, is a very capable ground attack aircraft that can destroy most anything on the battlefield. Before we start blowing things up though, let's first learn how to start up this bird and taxi to the runway. The first thing I'll ask you to do is turn on the electrical power by pressing right shift and L. With the electrical power now engaged, you can see that the heads-up display, or HUD, comes to life, as well as many instruments and cockpit lights. Before moving the aircraft, make sure that more than 3 minutes have elapsed in order to let the horizontal situation indicator gyro to align properly. Now that you have power, let's turn on the navigation lights by pressing right, Control, and L. Next, let's close the canopy by pressing left, Control, and C. Our next step is to start our two engines. Before you do so, make sure your throttle controller has a 0 power setting. Start the left engine by pressing right, Alt, and Home. With the left engine started, press right, Control, and Home to start the right engine. Off the lower left corner of the TV display is the engine gauge, with needles marked 1 and 2 for the two engines. When an engine is being started, one of the two green lights below the gauge will light. Once the light turns off, it indicates that the engine is ready for operation. In the lower left corner of the dash is an aircraft symbol that indicates the status of your flaps, landing gear, and air brake. Lower your flaps to the takeoff position by pressing left shift and F. We're now ready to taxi, so slowly increase the throttles by moving your throttle control forward or pressing page up. To reduce throttle, use your throttle controller or press page down. To use the wheel brakes, press W. Start rolling forward and turn to the left of the taxiway ahead. Press Z to steer left and press X to steer right.
Один, 02. Ассистент. Разрешаю руление на полосу 26.
Nice job, now heading in the right direction. Keep your taxi speed around 10 kilometers per hour as indicated in the top left corner of the HUD. As you taxi, use small, smooth rudder corrections to keep you aligned on the center of the taxiway. At the fork, hang a right to reach the runway. As we taxi, you can go to external view by pressing F2 and return to the cockpit by pressing F1. You can zoom in and out using the keypad star and / keys. Rotate the views using the keypad direction keys.
Man, I did poorly. But I was also watching a sea otter cam.
Welcome to this lesson on the basic flying and navigation of the Su-25T. This lesson will teach you how to get from point A to point Z and all points in between. I currently have the lesson in active pause. If you wish, you can turn on cockpit lighting by pressing L. Your airspeed is indicated at the top left corner of the HUD. The horizontal line below the airspeed indication, with the caret below it, indicates your acceleration or deacceleration. If the caret is on the left side of the line, you are deaccelerating. If it is in the center, your speed is not changing, and if it is on the right side of the line, you are accelerating. The smaller number above is your set airspeed for that leg of the route when you're in navigation mode. Press the spacebar to continue. Your altitude in meters is indicated in the top right corner of your HUD. An R to the right indicates it is radar altitude, for height above ground, and not barometric, height above sea level altitude. The smaller number above is your desired barometric altitude for that leg of the route. Press the spacebar to continue. You'll probably notice a circle in the center of the HUD. This provides you poor steering to the next waypoint. By flying the aircraft to align the circle in the center of the bank and pitch indicator in the center of the HUD, you will reach your next destination on the course line. The course line is a direct line between two waypoints. Press the spacebar to continue. In the bottom center of your front dash is a horizontal situation indicator for HSI that looks like a compass. The yellow needle points directly to your next waypoint. And the top left field indicates the range of kilometers to that waypoint. The top right field indicates your course bearing to reach the next waypoint. The double white needles points to your course intercept. When you're on course to the next waypoint, both the yellow and white needles will align. Press the spacebar to continue. Ahead of you are a series of gates to fly through. Fly through the first gate directly ahead of you. You can push the control stick forward to push the nose down and dive, or pull back the stick to raise the nose and climb. These inputs control your elevator. Use the throttle, the page up and page down, to control your thrust. Try to keep your airspeed around 620 kilometers per hour. Press the spacebar when you're ready, and I will unpause the lesson. Note that when you pass through a gate, the next one's sequence will become larger if it's rather far away. If you get too fast, reduce the throttle and toggle your air brakes by pressing B. The next gate is above you and to the left. To change your heading, use your aircraft's ailerons to roll the aircraft to the left by moving your control stick to the left, and then gently pulling back on the stick until you are aligned with the next gate. The next two gates are below you and to the right. This time, roll the aircraft to the right and lower your nose to fly through the gates. keep your nose level, try using the trim. To trim the nose up, press right Control period. To trim the nose down, press right Control and semicolon.
напор. Переведи в напор. Переведи в напор. Переведи в набор. Переведи в набор.
Damn dirty Russians.
In this lesson, we're going to learn how to navigate to an airfield and land on it. There are three navigation modes that we'll be using: en route, return to base, and landing. These submodes are selected automatically at appropriate points along the assigned flight path, but they can also be cycled manually. In this lesson, we'll use the automatic method. I currently have the lesson paused as I explain some of the finer points. Press the spacebar to continue. What we'll learn in this lesson is how to navigate to a waypoint using en route mode, switch to return mode automatically, and then switch to landing mode automatically. We're currently in en route mode, as indicated in the bottom left corner of the HUD. This mode allows us to fly from waypoint to waypoint sequence automatically, as we did in the prior navigation lesson. However, in this lesson, we'll try manual selection. Our current waypoint is 0, our starting point, as indicated in the bottom right corner of the HUD, with a range of 0. Press left control and tilde to manually select waypoint 1. Good. You will now see that waypoint 1 is selected with a range of 8.6 kilometers. Press left control and tilde again to select waypoint 2. You can see that waypoint 2 is 15.5 kilometers from us. As we learned in the prior lesson, you can see the direct heading of the waypoint is indicated by the yellow arrow on the HSI, and the twin white arrows indicate our path to fly the course line. Directly above the HSI is the Attitude Director Indicator, or ADI. This is a sphere with one hemisphere white and one hemisphere black. In the center of the ADI is a white aircraft symbol. This aircraft symbol stays stationary in pitch, but will rotate as you maneuver and roll. The ADI ball will move in pitch in relation to the aircraft symbol. When the aircraft symbol center is over black, your nose is below the horizon. If the aircraft symbol center is over white, your nose is pointing above the horizon. Press the spacebar to continue. In the center of the ADI are two yellow lines that help assist you reach the waypoint via the course line. The course line is a direct line between two waypoints. The vertical line indicates your required astral steering to reach and maintain the course line. When the yellow vertical line is centered on the ADI, you are flying on or to the course line. With the vertical lines off to either side, put your stick in that direction until the vertical line centers on the ADI. Adjust your roll to keep it centered. The yellow horizontal line indicates your elevation of course steering. When centered on the ADI, you are flying at or to the set course altitude for that waypoint. The yellow line is on the lower half of the ADI. Push the stick forward until the yellow horizontal line centers on the ADI and adjust pitch to keep it centered. Conversely, if the yellow horizontal line is above the center of the ADI, pull back on the stick until the line centers. Along the top and left side of the ADI are your heading and elevation deviation scales. The more the lines are from center, the greater you are off the direct path to reach the waypoint. Let's practice this as we fly to waypoint 2. I will unpause the lesson when you press the spacebar. You will first need to intercept the course line between waypoints 1 and 2. Note that the ADI steering bars and the HUD navigation circle provide us the same information. Fly the aircraft to center the ADI steering bars by adjusting the pitch and roll to keep the bar centered on the ADI. Or you can fly to keep the navigation circle on the HUD in the very center of the pitch and bank indicator. The choice is yours. Also remember that the assigned airspeed and altitude of the waypoint are indicated as smaller digits above your current airspeed and altitude. Fly to waypoint 2. Mission failure. Press escape to end the lesson. In the past two lessons, we learned the basics of navigation and landing under ideal conditions. In this lesson, we're going to put what you learned to the test by finding an airfield and landing on it at night during a thunderstorm. Sounds fun, huh? Let's turn on the cockpit lighting by pressing L. We're currently in route mode, but we have no airfield at the final route destination. So let's select return mode by pressing 1. As I mentioned in the last lesson, the airfield identification number is displayed displayed in the lower right corner of the HUD. 21 is the ID code for Beslan Airfield, the smallest runway I could find in the game, just for you. If you want to get return steering to a different airfield, you can press left control and tilde until you select the airfield you want. A complete list of airfield ID numbers is located in the back of the SU-25T flight manual. For now, let's keep it on 21. Press the spacebar to continue. Using what you learned about course steering through the HUD and ADI, fly the assigned return course that will lead you to the ILS intercept for Beslan Airfield. As you start to descend, you'll probably pick up a lot of speed. Don't forget that you can deploy the air brakes by pressing B. As we get closer to the airfield, I should also mention that not all airfields have Russian ILS, as we had in the last lesson. Airfields that do include Mozdok, Krimsk, Maikop, and Krasnodar Center. Being that Beslan does not have this, you will not have the HUD ILS indications. However, if you look down at your HSI, you'll notice a dashed cross in the center and both solid vertical and horizontal lines. The dashed lines are fixed and represent the optimal glide slope and localizer positions with the solid lines. Press the spacebar to continue. If the glide slope bar is below the dashed line, you are above glide slope. If it is above the dashed line, you are under glide slope. If the localizer line is left of center, you need to fly to the left. If the localizer is to the right of center, you need to fly to the right. You always fly to the needle. As you pass over the inner marker beacon, you may have noticed a little bit of crosswind from south to north. To counter this, input a little left rudder by pressing Z and add a little right wind. Keep your nose right on. Mission failure. Press escape to end lesson. In addition to the internal 30mm cannon, the SU-25T can also carry up to 4 SPPU 22-1, 260 23mm rounds. The fire rate for the cannons is 3,000 rounds per minute and have an effective range of around 2 kilometers. The pods are most effective against unarmored and lightly armored units. This lesson is currently in active pause as we discuss its use. Press the spacebar to continue. Enter air-to-ground mode by pressing 7. Activate the gun by pressing C. On the weapon status panel, you will see that we have 4 wing stations loaded. Each of these contain a single gun pod. You will also note that we have a full ammunition load indicated by the K. Press the spacebar to continue. Let's take a look at the Weapon Systems control panel in the bottom left corner of the front dash. Currently, the release mode switch is set to the salvo position and the size switch is set to 1. In this setting, just the internal 30mm cannon is used. Press left control and spacebar once to select the next salvo position. The fix option is now selected as the salvo position and the salvo size switch has been set to X2. In this setting, 2 gun pods are now the active weapons. Inside each of the gun pods, the twin barrels can be depressed to allow you to shoot downwards even when in level flight. When the barrels are depressed, the green light on the panel will light. Let's try this. Press right control and right bracket to depress the gun pods. Notice that when you did so, the range carried on the left side of the HUD decreases due to the change in gun barrel angle. Now try raising the gun barrels by pressing right control and left bracket. Good. To select all 4 pods in fixed mode, press left control and spacebar again. When you did so, the salvo size switch was set to X4. To set all the gun pods to the bore sight position, press left control and spacebar again. When you did so, the salvo position switch was set to the 0 position. To return the internal 30mm cannon to the salvo position and the salvo size switch set to 1, press left control and spacebar one more time. Do this now. Ahead of you on a small airfield is a light armored vehicle marked with red smoke to practice on. Set the number of gun pods to use in the depression angle and then use the aiming reticle on the HUD to line up the shot. When you have the launch authorization cue, press and hold the spacebar to fire the gun pods. Press the spacebar to unpause the lesson. Okay, here we go.
Пуск разрешен. 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 Переведи в набор. Переведи в набор. Пуск разрешен. Катапультируйся. Предельный угол.
In the event that something does go wrong.
Welcome to the cockpit overview lesson. Today, we will take a detailed look at the Mustang cockpit. You can use mouse look mode to move your view around the cockpit. To turn mouse look mode on and off, press left Alt plus C. Throughout this lesson, pressing the spacebar key will initiate the next consecutive step once instructions for the current one are complete. Press the spacebar key when you are ready to begin. The cockpit is configured in a standard layout, with the instrument panel positioned on the front dash, a center-mounted control stick, a throttle quadrant on the left side, and various aircraft system controls on the left and right panels. With the exception of the flaps control handle, which is located in the bottom left corner of the cockpit, most of the indicators and controls are well organized and easy to read and reach. Moving on to the instrument panel, the upper left corner houses the remote indicating compass. The compass unit is installed inside the left wing and transmits magnetic readings electrically to the cockpit indicator. Using a remote compass avoids the magnetic effects caused by armor plating around the cockpit, experienced by a standard magnetic compass. The remote indicating compass includes a heading needle, which shows the current heading, and a desired heading needle, which can be turned using the indicator knob to set a desired course reference on the indicator. To turn the knob, you can simply roll the mouse wheel over it. To the right of the remote indicating compass is a standard clock. The winding knob can be used to set the time. Doing so requires pulling the knob out with the left mouse button, then rolling the mouse wheel over the knob to rotate it. The suction gauge indicates the amount of pressure in inches of mercury being generated by the engine vacuum pump. Vacuum pressure is used by a number of vital instruments, including the flight indicator, bank and turn indicator, and the directional gyro. A suction reading above or below normal means the readings of these indicators are unreliable. Next is the manifold pressure indicator. This is one of the primary instruments used in flight, and together with the tachometer or engine RPM indicator is your main reference of engine power. The manifold pressure indicator shows gas pressure inside the engine induction system prior to entering the cylinders. Like the suction gauge, the indication is in inches of mercury. Manifold pressure is set using the throttle handle, while engine RPM is set using the propeller control lever, also on the throttle quadrant. On the left side of the middle row of the instrument panel is the airspeed indicator, which shows an indicated airspeed in miles per hour, mph. The red line on the indicator marks the maximum permissible airspeed of 505 miles per hour. It's important to remember that maximum permissible indicated airspeed is reduced as altitude increases. For example, it is 400 mph at 20,000 feet and 300 mph at 30,000 feet. In the left center of the instrument panel is the directional gyro, which shows current heading. The instrument can be caged and the heading adjusted manually by pushing in and rotating the indicator knob.
2. Engage armor.
In the center right of the instrument panel is the flight indicator, which shows the aircraft's roll and pitch attitude relative to the horizon. The indicator is limited to 60 degrees in pitch and 100 degrees in roll. The instrument can be caged or uncaged using the caging knob in the lower right corner of the indicator. The horizon level can be adjusted vertically using the pitch adjust knob. To the right of the flight indicator are two temperature gauges, the coolant temperature gauge above and the carburetor air temperature below. It's important to monitor these instruments in flight, as temperatures rising above normal may lead to serious engine problems, such as detonation and pre-ignition. On the right side of the middle row of the instrument panel is the tachometer. This instrument indicates engine speed in revolutions per minute, RPM. The pilot controls engine speed using the propeller control lever on the throttle quadrant. A propeller governor system automatically adjusts propeller pitch angles to maintain the RPM set by the pilot. Typical RPM settings in flight will be between 1,800 and 3,000 RPM. Moving to the bottom row of the instrument panel, the left corner houses the altimeter. The altimeter shows barometric or pressure altitude using a 3-needle system. The shortest needle shows altitude in tens of thousands of feet, the middle needle in thousands of feet, and the longest needle in hundreds of feet. The indicator knob is used to adjust the sea level reference pressure in inches of mercury to ensure an accurate altitude reading over a desired location where the sea level air pressure is known. Next is the bank and turn indicator, primarily used to maintain coordinated flight and minimize side slip. The vertical needle of the instrument indicates turn rate, and the slip ball indicates side slip or side skid. In flight, the pilot maintains the ball's center by using stick and rudder controls or aileron and rudder trim. Flight trim is very sensitive to changes in engine power and airspeed, so constant attention must be paid to the bank and turn indicator in order to fly as efficiently as possible. To the right is the rate of climb indicator, which shows the climb rate in thousands of feet per minute. Further to the right is the accelerometer, or G-meter. This indicator shows the G-load factor experienced by the aircraft, as well as 2 additional needles that show the maximum and minimum G-loads attained since the instrument was last reset. The instrument includes a reset button used to reset the needles to 0. Finally, on the very right is the engine gauge. This instrument includes 3 indicators: the oil temperature gauge, oil pressure gauge, and the fuel pressure gauge. Moving below the instrument panel, the engine control panel includes a number of important engine controls. These include supercharger blower switch, sets the supercharger to low, high, or automatic blower modes. Normally this should be set to auto. The jewel light indicator lights up when the supercharger kicks into high blower mode. Fuel booster switch turns the fuel booster pumps on and off. Oil dilute switch, used to dilute the oil with gasoline, which may be necessary when starting in cold temperatures. Starter switch, used to turn the engine prior to ignition during startup. Primer switch, used to feed fuel to the engine through the fuel primer system during startup. To the right are the 2 landing gear warning lights. These indicate safe or unsafe states of the landing gear. For example, the unsafe red light will be on if the gear doors are open but the landing gear is unlocked. Adjacent to the landing gear warning light is the parking brake handle. Setting the parking brake requires the following steps. Pull out and hold the parking brake handle. Fully depress and release the brakes. Release the parking brake handle. Releasing the parking brake only requires a press of the brake pedals. On the right side below the instrument panel are the oxygen indicators, the oxygen flow indicator, and the oxygen pressure gauge. The oxygen flow indicator features a blinker that opens and closes as the pilot inhales and exhales on-demand oxygen. The oxygen pressure gauge shows the amount of oxygen remaining in the O2 tanks in pounds per square inch, PSI. A normal reading is 400 PSI. Just below the instrument panel is the front switch panel, which includes a variety of important controls. Ignition selector switch selects the left, right, or both magnetos to operate the engine ignition system. Cockpit light switch turns on and adjusts the cockpit floodlights. Horn silence button silences the AN/APS-13 rear warning radar alarm. Below the front switch panel is the fuel control panel. This includes the fuel shutoff valve, used to open and close the fuel flow, and the fuel selector valve, used to select the fuel tank used to feed the engine. Correct fuel tank selection is important in flight to maintain a balanced aircraft. To the right of the fuel control panel are the hydraulic pressure gauge and the landing gear fairing doors emergency release handle. The landing gear fairing doors emergency release handle can be used to release the hydraulic pressure and mechanical locks holding the gear doors closed. This will open the fairing doors and allow the landing gear to fall down under its own weight. Slight rolling of the aircraft from side to side can be used to ensure the gear locks in place prior to landing. Normal pressure for the hydraulic system is 800 to 1100 psi. The surface control lock is used to lock the control stick in place when the aircraft is parked. Left-clicking over the pin locks the stick in a forward position, which leaves the tail wheel unlocked and allows the aircraft to be towed and turned easily. Right-clicking on the pin locks the stick in the neutral position, which leaves the tail wheel limited to 6 degrees of turn. Moving to the left side of the cockpit, the throttle quadrant dominates the forward section. The throttle quadrant includes the throttle handle, the propeller control lever, and the mixture control lever. In addition, 2 friction locks are mounted on the assembly and can be used to stop the movement of the throttle handle or the mixture and propeller control levers. The throttle handle features a microphone switch button used to activate transmission over the VHF radio. Moving back from the throttle quadrant, the radiator air control panel includes switches to operate the coolant and oil radiator flap doors. These are usually kept in automatic, but can be opened and closed manually when necessary. This panel also includes the landing light switch and the left-hand fluorescent light rheostat switch, which controls instrument backlighting on the left side of the cockpit. Three trim wheels are used to set the aileron, rudder, and elevator trim. Take off with 5 to 6 degrees of right rudder trim to help compensate for engine torque. Trim settings in flight may vary depending on flight conditions. The 2 handles toward the left rear of the cockpit control airflow to the engine induction system. The ram air control handle controls whether air is ingested through the main intake under the nose or filtered intakes on either side of the nose. Filtered air is used when icing of the intake develops. The hot air control handle opens a vent door in the engine compartment to allow warm air to enter the carburetor. This can be done below 12,000 feet when icing of the carburetor is a danger. Probably the most awkward control in the cockpit is the flaps control handle in the bottom left corner. The flaps can be set from 0 to 47 marked 50 degrees in 10-degree increments. The landing gear control handle is also on the left side. The handle is pulled in and moved up or down to raise and lower the landing gear as desired. The gear should only be moved when it's locked in either the up or down position. Now moving on to the right side of the cockpit, we have 2 canopy controls. The canopy is rolled open and closed by turning the canopy hand crank. The red handle is the emergency canopy release. When pulled, This will unlock the canopy and it will fly off into the slipstream. The oxygen regulator is used to control oxygen flow to the pilot's mask. The oxygen diluter lever, marked with yellow stripes, is used to set normal diluted oxygen or 100% oxygen. The red emergency valve is a separate backup oxygen line and can be used to bypass the regulator. The recognition light's keying switch is used to flash the recognition lights installed on the underside of the right wing tip when they are set to key mode on the electrical panel. The lights turn on for as long as the keying switch is held down and off when it is released. The electrical control panel includes switches for battery and generator power, pitot tube, and external lighting. In addition, the right-hand fluorescent light rheostat switch controls the backlighting for instruments on the right side of the cockpit. The electrical control panel also includes an important indicator, the ammeter. This shows current output of the generator in amperes. Maximum permissible output is 100 amperes. The ammeter does not show battery current. Finally, the electrical control panel also includes a circuit breaker bump plate. This can be pressed in to reset all the circuit breakers in case one or more of them gets overloaded and pops out. Further back from the electrical control panel is the AN/APS 13 Rear Warning Radar, or RWR. This device sounds an alarm when an object is detected behind the aircraft to warn the pilot of a possible threat approaching from the rear. Next is the SCR 522 VHF radio, used for communication with flight members and air traffic controllers. The radio features 5 channels, the frequencies for which are preset and cannot be changed in flight. You should consult your mission briefing prior to starting a flight to ensure your radio is set up to contact ATC towers in your vicinity. The remaining radio systems, including the homing adapter, IFF transponder, and Detrola range receiver, are not functional in this aircraft. Let's now take a look at the fuel gauges. You may need to twist your head around the cockpit a little to see them. You can press left Alt plus C to enable mouse view mode, and then hold down